This is my first video where I've combined two sections. You guys know in the past that sometimes the section's pretty short, and I usually just try to combine them both into one day. Same thing here. So, today we're going to do 12-5, circles in the coordinate plane on page 798 first, and then we'll get to 12-6, locus, a set of points on page 806. I'll let you know when that's about to come, so if you want to just wait on writing that heading in your notes, that's fine. Okay, so 12-5, circles in the coordinate plane. Well, here I have a circle, and then a coordinate plane, we talked about that before. Remember, coordinate plane just means a graph. So I have an x and a y. So my coordinates, my x, y coordinates. Now, if I have a circle centered on the O, or centered on the origin, rather, it would look something like this. So the first thing we need to talk about is theorem 12-16. The theorem is titled an equation for circles. So the equation for circles is this. Parentheses, x minus h parentheses squared plus parentheses y minus k parentheses squared equals r squared. Now it seems like a lot of goofiness, but what it comes down to is x and y, we're not going to mess with those at all. The things that might be different are the h and k. Remember, so here's my thing. H comma k is just a value where h is some x value, k is some y value. What that specific coordinate is, in all cases, is always going to be the center of the circle. And r squared, well, what do you think r is in regards to a circle? Well, r would just be the radius. So if this was drawn properly and my center was 0, 0, and my radius was some value, let's say 4, I would write, well, x minus 0 squared plus y minus 0 squared equals 4 squared. And then there's a simplification I could do. So x minus 0 squared, that's the same as x squared and y squared. You can only do that for the origin, because if there's other stuff like x minus 1, just leave it in the parentheses. Okay. 4 squared is 16. So that would be a very base case, where in this case, again, my center is that h comma k. Example 1, write an equation. Okay. So, sometimes you're going to be given the information about the circle. For example, let's say the radius is 7. And its center is at 5, -2. Now I could go ahead and graph these, take a look at it. If you ever want to graph something on your computer, you can go to desmos.com/calculator, I believe. Or if you just Google like Desmos graphing calculator, it should be the first link that pops up, and you can just type in an equation, hit enter, and it'll graph it for you. But if we were to graph it ourselves, let's say, boom, boom, centered at 5, 2, well 5 would be my x coordinate, -2 would be my y coordinate, so 1, 2, 3, 4, 5, 1, 2, my center would be somewhere right here. And I would have a radius of 7, so 7, and I could draw a circle all the way around. Wow, that's a terrible circle. That's better, but not not going to make a target there. But I don't really need the graph because I have the pieces. So I can just write my formula, x minus h squared plus y minus k squared equals r squared. Now I need to look. First of all, my r is pretty easy, so 7. So r equals 7. My center is h comma k, so h has to equal 5, k equals -2. So I can just plug it in. X minus h, well, x minus 5 squared plus y minus k. So y minus -2. So if I subtract a negative, that's the same thing as adding. So I get y minus -2, or like I said, plus 2 equals 7 squared, so 49. So my equation would be x minus 5 squared plus y plus 2 squared equals 49. Example 2. We're going to write an equation, but we're going to use the center to find radius. So if I tell you that the center is 1 comma -3. And I tell you that the edge of the circle is at 2 comma 2. Well, let's just think about what that means. Well, if my center is here for any point, not necessarily in the coordinate grid, but it's of a circle, and my edge is out here, or my edge is somewhere out here, well, how can I find the radius? Well, the radius would just be the distance from the center to my edge. So my radius, in this case, I would have to use the distance formula. I know you guys are all excited. You guys probably, I'd guess 90% of you groaned right there. Okay. So remember the distance formula, d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So in this case, I'm going to need to label some values. So I'm just going to make my center x1 and y1. Again, it doesn't matter. And my edge would be x2, y2. All that matters is that my 2's are together and my 1's are together. So I get 2 minus 1 for my x values. 2 minus 1 is 1. 1 squared is 1. I get 2 minus -3. Again, subtract a negative is adding, so I get 5. 5 squared would be 25. 1 plus 25 would be 26. And the distance, again, is the square root of that. So my distance between the center and the edge is the square root of 26. That's also, again, as we said, our radius. So now all we got to do is write an equation for our circle. Well, again, x minus h squared plus y minus k squared equals r squared. Where, again, if h and k are my center, my h has to be 1, and my k has to be -3. So I get x minus 1 squared plus y plus 3, because again it's a minus negative squared, equals r squared. Well, if r is square root of 26, what would be the square root of 26 squared? Well, just like when we often have x squared and try to do the square root to cancel it out, square would undo that as well. So we get x minus 1 squared plus y plus 3 squared equals 26. And that's actually the end of 12-5. Okay, so now we're going to go right into 12-6. A locus, a set of points, and that's why you can see I kind of combine these two together, because 12-5 is short, and so is 12-6. Okay. And we're back into another section where we kind of have a new vocabulary term. Let's see, if you're skipping around, no, we're in 12-6 now. Okay. So now we again have a new vocabulary term. In this case, we have locus. So, locus is very interesting. Well, the subheading already tells you what it is. Locus is just a set of points that follow a restriction. All I mean by that is it follows a rule. So for example, let's say we have example 1. Describe a locus so we need a rule, first of all. So let's say it has to be 4 inches away from point P. Well, first of all, we need a point P. That's as good a point as any. Now, we need to list a set of points. All a set of points is just all the possible values that follow that rule. So let's say I have a ruler, and I just want to start listing some points, Mad Lad style. So let's see, 4 inches away from P, well, that one is. This one's 4 inches away. So that's one of my points. I need one over here, let's see here for sure. That's 4 inches away from P, just in a different direction. That's 4 inches away. That's 4 inches away. And I can continue doing this a whole bunch, or I can start to see a pattern. In this specific case, 4 inches away from point P would just be a circle, where P is my center, and my radius would be 4 inches. So, my set of points would be all that entire circle. That'd be my locus. Okay. Let's get a little trickier. Let's say, 6 inches from segment AB. So first I need a segment AB. Now on your paper, if you want to use less values, that's fine. Like if you want to use like 2 inches or something, I just need something just so you can see it from the camera. Okay. So, in theory, I could look at A and say I could draw a circle that's 6 inches around it. I could draw a circle that's 6 inches around A. Now the problem is, once I start completing it, this line, this black, would get closer to this rest of the segment and I wouldn't be able to finish it off. So I need to also maintain 6 inches away from this segment at all times. So what's kind of funny is it kind of, in this case, would flatten, oh shoot. That just made it worse. It would flatten off along the segment until it would round again. So that locus look kind of goofy because it has to again maintain 6 inches or whatever value decided vertically from those, and then from the corners it have to be 6 inches diagonal, and then like 6 inches here, etc. and etc. So this one's kind of an interesting one. Whereas a point, it would just be a circle. Okay. Now, those are locus that follows one restriction. We technically can be a locus that follows multiple. So, example 2. Two restrictions. Okay. So our first one is, let's say, it has to be 2 inches from segment GH. It has to be 2 inches from GH, but also 4 inches from G. Actually, I want to make 4 inches from G in a different color. 4 inches from G. So here again we have 2 restrictions. So first I'm going to need a segment GH. So the way we go about doing this is if I have 2 restrictions. If I have 2 rules, I do this step process. First step, we just do each rule individually. And then we focus on the overlap. So, first I need to do 2 inches from G, which as we said, if I buffed it on a ruler, it would look something like this, where my segment would just be 2 segments away, and then it would do something like that. Okay, that would be 2 inches from, I'm going to make that in purple. Duh, I color coded it and then I didn't use the color code. So again, 2 inches from GH the entire way around. Now I also have to do my second one, which is 4 inches from G. So that's 2 inches, 4 inches would be something like this. Yeah, not very precise, I'm aware. Okay, so my actual answer would be everywhere that they overlap, or in this case, those places intersect. So here would be a solution, and here would be a solution. Because it's 2 inches away from GH, and it's also 4 inches away from G. So yeah, 2 in from GH, and 4 in from G. So my locus would be this point and this point, let's say, I don't know, X, Y. So that's what happens when we have 2 restrictions. I encourage you to do each individually and just see where they overlap. That's all of 12-6 as well. Again, 2 very short ones. Thank you for watching, and I hope you have a great week.